Hello everyone. I hope you're all having a good day, and I would like to welcome you all on behalf of Stratview Research for today's session. Before we proceed with this session, let me tell you a bit about myself and what we discuss today. My name is Aniket, and I'm the Associate Manager at Stratview Research. We consulting firm specializing in the chemicals and mobility domains. And today's session is going to be about the much buzzword in the industry, that is AI. So, for the past several months, whoever we have been talking to, regardless of the industry, we have seen one common thing in their technical roadmaps for the year, which is AI. And regardless of the department working, regardless of the sector, if you ask them what are your plans this year? So somewhere in the responses, there's always some around AI. So with that, we decided what take this discussion to the industry which all of us love, which is the composites industry. And so for that, we have this session today. And today we'll be discussing basically things around what AI has to offer to the composites industry, what the reality of this hype is for, mostly like awareness stage of different people associated to this industry and things like that. Apart that, on a professional level, I'm also currently working on a white paper myself, which discusses this topic further in some detail. And to help me explore this interesting territory, I have with me two experts, Jamie and Praveen. So, hi Jamie, hi Praveen.
But
Hey, Aniket. Thank you for having
Yeah,
us.
yeah, it's a pleasure. So, allow me a moment to introduce both of our experts who will be participating in today's session. I'll start with Jamie. Uh, Jamie is currently the sales director at Pliable. Pliable is very of AI in the composites industry. And Jamie has like more than 15 years of experience in the composites industry with a PhD in composites manufacturing. And throughout his career, Jamie has been involved in several initiatives regarding the advancements of composites industries throughout different companies. So it's great to have you on board, Jimmy. Thank you for joining us today.
thank you for having us.
Then we have Praveen from Ad Composites. So Praveen has been the CEO of Ad Composites for the past 9 years, I think. And prior to that, Praveen has been part of prestigious organizations like ISRO, the Indian Space Research Organization, and Cell Composites. And Praveen has been elemental in driving the key initiatives at all his previous organizations, and he tells us that he's a very much innovative kind of guy. So it's great to have you on board today, Praveen. Welcome again. Thank you for
Thank you, Aniket.
joining us today. So if everything is settled, I think we are good to begin.
hmm
Okay, that's the first question for you, Praveen, and that is regarding like we are everywhere we are going, we are hearing everything about AI. Everyone is talking about AI. So, what have you experienced at your level regarding the awareness among the industry, and where do you think like your company at Composites stands at this place?
Sorry, I lost the.
I think there he is.
Hello?
Sorry, can you repeat the last part of the question? I kind of lost it.
Yeah, yeah, no issues. So I'm asking like, what do you think is the awareness stage of the industry regarding AI, and how your company at Composites is making the scenario better?
Yeah. So I think that this is just based on my experience. So I'm involved in like about 5 or 6 European projects, and also about 50 50 plus systems that are running like more digitization trend in AFP side of things. That's what Ad Composite does. We provide automated fiber placement system, and through what I have understood, that everybody is using AI to their limited scope, clarify some basic doubts or so, and nobody has kind of indulged into to um, detailed specifics of building something out of it, or having something very specific to use in their analysis or so. And this is just my read based on last year's interactions.
Mhm,
What I feel, though, even though where I have not interacted, I publish a newsletter actually every day, and in there, what I see, there is a lot of adoption happening in certain parts in the additive manufacturing sector, which is what we can call like a bit close sister branch of manufacturing to composites. It's also additive. Composites also additive. So they are doing a lot of path optimization, design optimization that is suggested, supported by AI. And then there is the um, process optimizations, even the machine building optimizations. There's a 5 axis machine that you can find with 3D printing that is built completely with the AI, or the generative AI as a defining for the stress factors to define the structure. So there are certain areas where what we can say that we are seeing, and kind of taking from there. I think there is from a professor from Purdue University. They have a project in this regard where they have the kind of, if you have any questions related to composites, materials, manufacturing, and such, they've launched this composites AI kind of a chatbot type of interactive,
mhm,
which runs on the RAG architecture. So I think there is like uh, kind of things which are popping up, but on a wide note, nothing extraordinary yet. In Ad
mhm,
Composites, I think we use already AI. Think maybe 2 to 3 years ago already, to defect detection during the AFP. Now we also do defect detection already at the simulation stage, while
mhm,
we are planning, and actually also, and for all this we basically use the like a CNN basis, slightly older form of AI, not the transformer style of AI. These are more vision based AI. Um, but I think given that the recent, if I have to take some example from the recent AI, these are very good at writing codes. And so what we have done, actually, we have built free tools for the composite community to be able to use, and these are built completely using this type of generative AI. We don't charge anything, so you can go. We have 3 tools. One is for if you want to, optimize your layup. It's all mathematics
mhm,
that is ground, well founded even back in 70s, and just that is deployed free of cost for everybody in the community to follow. Same for the infusion simulation, and then also one of the recent things for motor sleeve design, if you want to make a composite motor sleeve for your electric motors and such. And so we build this type of tools. So this is how we have built, like used AI within Art Composite to build this free of cost tool to and I think enable more design capabilities within the community.
mhm.
Yeah, I think that would be, yeah, yeah.
Okay, that's great to know. So, you think that there are point adoptions right now, and the adoption is not uniform. Like some parts have adopted well, some nodes in the process. Okay, that's a great point. And thank you for sharing about the tools. I think we'll definitely tell our audience how they can access that at some point later in the discussion. Now, coming to you, Jamie, what do you think you have observed, and what do you think the scenario looks like for AI in composites manufacturing, and how pliable is making it better?
That's a very good question. I think AI as a topic is enormous, and I think everyone has very big expectations of what AI can do. But as if you start to then dig into the details and split out the different aspects of where AI can support, I think it needs to be reframed as a just a tool, a helping tool um, to improve productivity, to reduce waste, to help companies scale. One of the biggest challenges with composites is just the number of variables and the number of parameters in the production process, um, alongside the just the nature of the markets that use composites that are very highly regulated. Aerospace adoption of new technology is incredibly difficult. Automotive,
Mhm.
the rates need to be very high, really. So you need to be able to demonstrate very quickly and robustly that any new technology works there. Defense, they have their own challenges with data and just control of where the data goes. So um, it's it's looking at where the lowest hanging fruit is for adopting these new tools. If you take like ChatGPT or Gemini or all of these new tools, if you think about it, most people are just using them as new search engines and that. So if you look at that from a composites perspective, look at the areas that quite a lot of data is or data or tacit knowledge is used, but there might be ways of bringing in new tools without affecting, say, the end part, so qualification isn't needed, or whether it's just supporting existing teams scale. I think that's where the short-term opportunities are. So that's where we're focusing at with Pliable. Pliable looking at the tool design for composite parts, looking at the quoting process, the sales process as well. There's a huge amount of data and a huge amount of tacit knowledge built up in each composite part, each composite mold, relating to all the different processes. But being able to support existing engineering teams, existing sales teams in showing, giving recommendations, so helping with that down selection. So we're not looking to solve the problem, we're looking to just support the people who are currently trying to solve the problem in solving it quicker, more accurately, more effectively. So Pliable's machine learning algorithm, it takes a CAD model of a part, it'll break it down into individual features. It can match those features with the training data, the subsets that we already have in the training data. So, if there's specific types, geometry, type curvatures, or overhangs in the part, or holes that are close to the edge, or local pad ups, all of these things, because there's enough data available to us from training data sets that we've built up over the last 6-7 years that Pliable's been in existence, it gives us the
Mhm.
opportunity to point people in the right direction. So we can create from that immediate costings, because as well as the data on the parts, we've got data on the on how much it costs to manufacture those parts and manufacture the tools. It can give you lead times, so it works out how complex the tool needs to be, and applies factors to give you a pretty accurate lead time. So that's how it's helping sales teams. That's how it's helping
Mhm.
procurement teams, because instead of having to wait for a tooling supplier to come back and quote you, even if it's just for an RFI response, even if you just need the information for a cost model yourself, we can
Mhm.
provide that data immediately, so we can help people be more productive and more efficient. And we can also provide the auto-generated molds. So if it's a very simple part, the algorithm can automatically generate a mold CAD that would work. If it's more complex, then obviously it becomes more difficult, and there's limited data on very complex parts. So it'll come up with I always say a preliminary design. So it's speeding up engineering teams because it's creating a CAD model that can then be fettled, and it can highlight where more detail needs to be added. It can highlight where there might be design for manufacture issues. So it's not replacing the engineering teams; it's just providing support to the engineering teams. And I think by reframing AI technologies in that perspective, it becomes a lot easier
Mhm.
to be introduced into manufacturing.
Okay, that's great to know, Jamie. I think Pliable is pretty much targeting every node there is to optimize, and
Yeah,
I would like to say, like for composites manufacturer, Pliable is going to be the next Jarvis. Correct? Jarvis is an AI assistant basically, which helps with everything. You mentioned that you are not focusing uh, towards solving the problem, but to assisting in a better way. That's why I said it.
yeah,
Mhm.
yeah. That's
Okay.
it.
So, like you mentioned a lot of applications yourself regarding where we can implement the composites in the composites manufacturing. And regarding that, we have uh, conducted a survey in which we like asked about 50 to 60 participants what they think is going to be the biggest application. And let me just share the results with you once. Okay, so here are the results that we got from the survey. And during the survey, we like had participants from companies of all sizes, from small, mid, and large companies. And we tried dividing the applications into two basic parts. First one was asset tracking, what I think is more or less Pliable is doing, which is when does the material arrive, where is it stored, what's the shelf life, when does it come out, and things like that. All that comes under asset tracking. And then there's design and process optimization, which is more focused on the quality approach, like how we can have weight savings and what layup method can we optimize, things like that. And so this is the response that we got from our participants. Now, coming to you, Praveen, where do you think is going to be the biggest application of AI in the composites industry? Do you think it will reflect what we have been able to capture so far, or do you think it will follow a different trend?
Um, I feel like it's a very tough question to answer because it's quite uncertain, given how the capabilities develop, and the thing is still quite new. Um, but this is my like more wishful thinking, I would say. So I would wish, because as a engineer who have done some design work in this field, which is very complex. So the moment okay, I would like to design, let's say, a part of a wing structure or a part of a fuselage or a section of a boat or such, I know kind of the load scenarios I'm going to be getting, but I would like the design portion to become easy. And it's not that design that okay, I'm only kind of just getting my ABD metrics. Okay, those are telling me that okay, now the stresses are balanced or so. But the composite comes with the challenge that because you're have to make sure that the manufacturability is there, that the qualification should be possible, and what material, and it should be from the not some hypothetical material that's something I could get in this particular region. So considering the once, because the design space is so huge, and also now, because I think as kind of what Jamie pointed at, is also like now it's possible to have the tooling kind of also designed at the same time. So you have to really also think all of that aspects in one single go. And that's what I would like it to kind of be able to do. And it's more wishful thinking that, okay, I want to make, because and this is a typical problem for any person who has worked in composites industry, because they get a request from a metal industry person, hey, we used to make this out of metal, can you make it out of composites? And they would just think of okay, exactly this it will look like, and it will be carbon fiber, and that's it. No, that never happened, that never goes anywhere. So that's kind of where and that person's problem is what I would like to solve, that so that they get entry into the composites easily. So they're like, okay, so they could ask their AI, hey, I have this part. If I would have to make it with composites, like a good carbon fiber composites, how would I be able to make it? And it kind of, gives them a design scenario which is actually practical, with the tooling, with the layup, and with kind of also more a process idea, maybe some cost estimation as well, maybe very rough, but that could
Mhm.
allow for the whole industry to grow from what niche it is, because it's such a tight knit industry. Pretty much, I believe I know every other company in the industry or somehow connected with them. Um, and that knowledge is not out to the actual, you can say the bigger part of the manufacturing industry, which are completely unaware that there is like this material. Everybody thinks it's too complex and not mass producible, and which are not true anymore. But still, that is the belief. So that would be my wishful thinking for the AI to solve. If that's the magical wand, if I could use, yeah.
Mhm. Okay, great. So you would want AI to help you with your design and the optimization part more than just the asset tracking part, correct?
Yeah. I would maybe more than that actually. Also select a process for me, select a material for me, select the tooling for me, and such. Yeah. So it has to be acceptable to all those levels. Yeah, not only get my stresses right. Yeah, which is what typical design means. Like you do an FEA, you get your stress, which are fitting within some failure criteria, and you're like, okay, I'm done with my design. Now I can go to production, and no, that's not how actually
Mhm.
in composites it's work. You have to think of about 100 things, and yeah, that complexity I wish AI to solve. Yeah.
Yeah, that would take a lot of uh, work off the shoulders, I think, definitely. So that was really insightful to know, Praveen. Now coming to Jenny, personally, would you like to add something to what just Praveen said, suggesting regarding the applications?
I broadly agree. I think composites in particular is ripe for improvement through AI, because of the number of different data points, the number of different parameters, the different options. That it's no one is an expert in all of it. What I would say is, I think the one of the key opportunities as well. So not so much in the kind of design and the development side of it, but also in serial production is um, I think AI will go hand in hand, or is going hand in hand with automation, the physical automation. It's a bit like what Ag Composites do. It's AI can enable the use of automation in industries where, although material throughput is very high, say for the A350, where a lot of composites is used, all of the different there's a lot of different components, and when you break it down into the individual components, you're not actually producing that many of that one component. Unlike in automotive, where you'll have a production line producing hundreds of thousands of the same part over and over. So I think that's where AI can support in being able to enable automation for not just economies of scale, but economies of scope, where you can have 100 different product lines being produced off the same piece of automation. But then also on the validation side of it and the quality assurance side of it, you're going to have a huge amount of data coming off that equipment. So then you can use the AI technologies that are being developed to be able to assess, to make sure that process parameters were all roughly within allowable limits. And if they weren't, go into that kind of investigatory phase where it'll tell you roughly why and provide feedback to the quality engineers to say, you should probably look at this. And then further on, look at the quality control part of it as well, where you can massively increase the amount of inspection and the speed at which inspection occurs. So instead of inspecting in batches of one have 100, one have 1,000, you could have 100% inspection, but not then have any detrimental effect to your production speed and your production cost, because it is just very quickly checking, whether it's it's a visual inspection and it's identifying any defects on the surface, whether it's say an inspection of a tape that's just been put down, thinking again about AFP. It means you can massively increase the uptime of your equipment without having the trade-off of having reduced inspection or reduced confidence. So I think that's probably where I'd put my chips if I was having to bet on where AI will be most useful from a manufacturing perspective. Is just speeding up processes and having that kind of symbiotic relationship with the physical automation.
Okay, so thanks for the input, Jamie. I think it's great to know that both our experts have more or less similar vision regarding the applications of AI in the composites industry. And now building upon that, uh, you mentioned a lot of applications, but I want to know next is that how far are we in achieving such assistance from AI tools, and what major challenges you think the industry might be facing regarding the adoption, Jamie?
I think the biggest two or three biggest challenges, thinking out loud, one is trust. Even if it is just providing recommendations to existing quality teams, design teams, things like that, it's building up that trust that it actually does work. And particularly in the aerospace industry and defense industry, where it's so highly regulated, and if a mistake is made, it is very bad. If something goes wrong and a plane falls out of the sky, it's going to be building up that level of trust to get to a level of adoption that would mean that the companies get the most benefit. I think that's the main one. The second challenge will be data. Really, for AI to work, you do need to have a huge amount of data that you can use as training data. And in industries like ours, it's people like to hold on to their data. From Plardon's perspective, it's a good kind of early adoption of AI because we don't need a huge amount of data, and it's the data that we need isn't particularly sensitive. But if you were to adopt AI from a much wider scale, and particularly in manufacturing, and particularly on parts that are going to be on aircraft, I think the biggest challenge is just going to be that level of trust, and it will need a combined effort from the manufacturers, the AI developers, the certifying bodies, the airline operators, the trust from the public as well. Would you fly an aircraft that has been mostly inspected by computers? That's going to be the big one.
Okay. So you think trust and data are going to be the two biggest challenges. Now, what about you, Praveen? How did you analyze the, will be the biggest challenges, the adoption of AI?
So I think I kind of got the question. So what I would say is I completely agree with what Jamie had said. That I definitely feel that would be definitely given the industry where composites is most prevalent, is aerospace, space, defense. Because we have, I think we kind of have a rule of thumb, like about 10 years to adoption for any new part change or any design change. Given, even though, even if today we are able to demonstrate some concrete improvements to make it to actual production in a flying object, it's far. And it's kind of by design because we want the flying and everything to be safe and such. um in the On the other side, what could happen is and which is kind of is happening, but that's kind of where we have to maybe slightly broaden the view, where we start to think outside EU and Western side of things, and we go more towards China and what's happening in the developing world, where the regulations are slightly, you can say, boundaries can be pushed slightly beyond. There we will see this to get adopted slightly faster. Um, and as we see already, the smaller the UAVs, or what you want to call the flying taxis, they are getting built faster there, exactly for the reason, because there is less regulatory framework they have to jump through. um, and it's kind of where I would say maybe that pushes us, and that 10-year timeline that I said, that kind of shrinks down because of that. um, and that's kind of where the adoption would look like. So with this dynamics, because the moment we realize that, okay, we are losing the battle, I'm pretty sure there will be few startups or young companies would push and try to get this also going faster on our end. Definitely the bigger giants will take their time, but I think for the younger companies, I think they would definitely like to push this as much. I think the best case of this I saw very recently was a completely 3D printed engine by two French mathematicians. And if you think of like a rocket engine design, production and such, usually I have been part of this process, and we took about 5 years just to qualify a composite nozzle or so, and they did it like in 6 months or so. And I think that's kind of where those type of jump we can see. And hopefully once that type of a push comes and shows that there is a huge benefits, then the startups or the younger companies get pushed, and they showcase, and then the bigger companies also join the hand, and that increases the adoption. But the trust and the regulations will push back. So we see who wins. In Europe, usually we know the winner, but yeah.
Okay, definitely that was very insightful to know. We also like a part of the study which I mentioned during the beginning of the session also involves identifying the market, and so we also conducted a survey regarding the same, and the results are a bit different. I would like to share. Uh, whatever whoever we asked, like who they think would be the biggest roadblock, we have most of the people thinking that skill difference or skill gap is going to be the biggest roadblock. So, what's your opinion on that? Do you think like there's a huge skill gap that exists right now?
I'd, I'd probably disagree with that. I think the technologies being developed in AI will support probably more people becoming skilled um, within engineering. You know, it can be used as a training
Mhm.
tool. And as I going back to my point at the start, the um, you know, the ability to support decisions with more data. Um, you can probably go back to, you know, when FEA was introduced, or CAD packages. You know, that I think, I'm sure at that point lots of people who were working in the drawing offices were thinking that that's their job over. But really, aircraft companies have massively expanded because an aircraft designs have got better and more optimized. Um, yeah, I think the biggest challenge to overcome, um, it'll be the relativity or the appropriateness of the AI tools to a particular skill or a particular um, process. Say, you know, I think a lot of people are aware of what AI can do, but how relevant is it, and how can it be relevant to um, a specific industry or specific skill or specific process? I think that's the bit that might be missing. That jump from we know this thing exists to how can it help me? And I think I think that's probably the jump that needs to be made.
Okay, so it's more of an awareness issue rather than a skill gap. That's what you're saying.
Yeah, I think so. I think a kind of a specific awareness and interest in what
Mhm,
you know
mhm,
what it can do, and I think a lot of
mhm,
that is the fact that it's particularly AI for composites. You know, a lot of our
mhm.
companies are very small and just growing. So just being able to get that awareness and get that visibility out there to the right people, I think is one of the key challenges of getting the technology adopted.
Mhm. Okay, great. That's great to know. So, before I jump on to the next question, just a note to the audience, and that is like we plan for this session to be as interactive as possible. So, if you have any questions for any of our experts, please feel free to drop the questions in the comments, and we'll be taking the questions shortly. Now, coming back to the discussion, Praveen, you just mentioned during your previous response that uh, the big companies will be the ones to adopt things fast, things faster, but they will have to like follow a more structured procedure when it comes to part approval and everything. So that brings me to my next question, and which is like, which segment do you think will benefit more through the integration of AI? Is it going to be the big companies, or do you think it is going to be the mid-sized and small companies in the composite space?
So I would just like slightly rephrase because I what my answer was that they will be slower, bigger companies,
Mhm.
because they have to follow a structured approach.
Yes.
But yeah, the winner is will be the fast adopter. It can be either big companies or also small companies, and this is a kind of just the law of numbers here. That if it's a smaller company, the law of number dictates the complexity is less, so the adoption will be faster. So then you will have the benefit of faster adoption, and but there is like a definite roadblocks that the um, in our industry that someone has to overcome. So everything is a function of how many parts are manufactured using composites today in that are getting end use. So there is airplanes, there is defense, there is space, and this is limited and kind of rail guarded by some big companies, and those are kind of the key deciding factors of who will benefit in the market from them. So the smaller companies, even though they have innovated, they would have this, kind of issue that they have to still sell it to the bigger companies, or their services, or the software they have developed, or the know-how they have developed, and they have to get them approved to their bigger processes. So there is a kind of interlinking between the smaller and the bigger companies that you need to see. Unless what happens is like the smaller companies open a completely new market where they kind of can drive the growth of okay, how many parts are getting produced, and they are using the material that is let's say I give like an example once again, aerospace material, the impossible to get your hands on to. and you go to the other side where you have the like you can get if because now new Chinese players have come in, and not only Japanese for carbon fiber exist. So assume that changes the dynamic and that material becomes more freely accessible. Let's just say that. Then it becomes like a dynamic that okay, uh, these companies can thrive. So there are few dynamics that has to change in the supply chain side of things, material side of things. Then the younger companies can definitely go ahead and will definitely be the winner. But the bigger companies still hold a lot of sway in how everything is getting consumed and deployed and such. So even though you can innovate faster as a younger company, unfortunately there is a bit of limitations that comes to because we are working in this ecosystem that we have to abide by. you know, yeah, there are only that many plane companies, there are that many satellite manufacturers, there are such things.
So do you think that anytime soon the bigger companies will be willing to share their data with the smaller companies just so they can adopt things at a faster pace?
No, no. I think
Not
that
gonna
would
happen.
be very unlikely, specifically due to all the
Mhm.
NDAs in place, all the other
Mhm.
rules and regulations. I would say that it would be possible that they deploy because now this type of transformer models you can deploy internally with very good internal structures. So you just have internal servers and you deploy, and they get a bit of a better speed to their own work. So that is what can be expected, and they become more efficient because they can do, let's say if a quality assurance person needed to be there standing next to the job when the hand layup is going on, they have to take all the notes. Now there's a camera, the computer vision is taking all the notes, and then there is a human verifies at the very end, okay, all those notes are correct, or such. So now you don't need a person to be standing there for 8 hours. They can just come at the latest part of half an hour. So this company can become smaller, and that could automatically make them efficient, benefit, and that overall reduces bureaucracy, and that can accelerate things. But I don't see such big companies actually sharing any data outside. It kind
Mhm.
of yeah, it harms their own competitive advantage. I don't know why would any company do that. Yeah.
Mhm. Okay. So do you think that cross-node collaboration would be an issue? And I would like to ask this to Jamie as well. Like, do you think that, like, if we are talking about the optimization part, we have several stages in the optimization process. Let's say if company A is optimizing at stage one and company B is optimizing at stage four, do you think that cross-node collaboration difficulty is going to be there? And how do you think it should be resolved?
Good question. Um, I think the key challenge will be if the companies are competitors. But I think if there's
Yeah.
different stages of the process, different stages of optimization,
Mhm.
um, and it can be seen as a collaboration, it goes back to just commercial discussions. And I think if the data that is being shared can be anonymized and ring fenced, and people can be convinced of that, then I think it's all possible. I think it goes back to trust. That the key thing will be making sure that if they're or let's talk in terms of motorsport. It's a really good example. If a company's wanting to work with Mercedes and Red Bull, um, Mercedes aren't going to want to give away any sort of data if they think, oh, actually, AI company is going to take our data and somehow it's going to get into the hands of Red Bull. That's going to be an immediate stop. But if you can demonstrate that, it's all anonymized, you wouldn't be able to, or company B, Red Bull, wouldn't be able to recognize any data or have access to the specific data from Mercedes, which that's kind of how Pliable is working, because obviously we work with, well, we try and work with all the aerospace companies, all the automotive companies, all the motorsport companies, but no one has access to that data, and
Mhm.
even if someone did manage to access the data, it's not in any sort of readable format. That means it is, we don't, although we have the best secure cybersecurity possible, even if that was compromised, the data wouldn't. It would be very difficult for someone to actually use that data. So I think that's the way around it.
Mm-hmm.
It's just making sure that people are aware and understand that it's the data is in a black box somewhere as opposed to freely available.
Mm-hmm.
Yeah, I think
One of the
that's probably it.
one of the other thing I could add to what Jamie said here, like I think if you can think of it like in terms of ecosystems, kind of going against ecosystems. So, and I give this as an example. So let's say European composites industry, you can think of it as a unified body, and they are thinking, okay, we as an ecosystem want to be competitive, and then there is the Chinese ecosystem, there's the US ecosystem, and so and so. And if we collaborate within European ecosystem, we can actually gain advantage as a full ecosystem. I think it start to benefit, and I think that's kind of maybe what Europe tries to do with the European projects. But also, I feel like if that is the thinking, that could really push forward the collaboration, and it still keeps the market quite competitive, because within the ecosystem also there could be different collaborations happening and fighting each other off to get better, building better collaborations, and gaining trust. Um, so I think, yeah, that could be to what addition to what Jamie said, that there is like a good layer of a technology stack that definitely anonymizes, make sure nothing gets IP is clear who owns what, and then nothing gets shared, but still all benefit from the cumulative data source, and then the ecosystem benefits overall because it becomes more competitive now against other. Because in the end, when it comes to buying something, a buyer is thinking, where do I buy it? And they have to choose a location, or a seller or so, and the whole ecosystem actually in the end decides the price. So yeah.
Ecosystems is what we should be focusing on developing, not point solutions.
Yeah.
Point solutions won't be able to transfer data smoothly, right?
Yeah, it's a
Okay.
very good point. Yeah,
Mm.
Okay, that's a very interesting perspective from your end as well. Thank you. So I think we have a lot of questions in the comments, and if you think it's right, we should start taking a few of them.
definitely.
Okay. So the first question is from Naresh Chandra, and he asks, "What about the use of AI for C-scan NDI to speed up the process and improve reliability?" Jimmy, would you like to take up this question?
Yeah, sure. Yeah, I think that's a very appropriate use of AI. Again, it's the C scanning is creating data that an inspector is still having to check. Um, so having an AI layer to highlight or identify potential defects that that might have been picked up by the C scanning, for the inspector to review is very I'd say pretty, to use the term again, it's very much a low hanging fruit, because I don't think you would ever trust the AI to inspect and make a decision on the C-scan data, but by having that ability to flag up to an inspector, it would speed up the process hugely.
Okay. So,
Yeah,
like,
I
do
just
you
one
see?
thing, Aniket, I would add to that
Yeah,
is
sure,
like,
sure.
I think that's also like you can apply that to pretty much all the tasks in a
Mm.
way. So let's say defect detection, or kind of quality assurance. So all the tasks of that can be taken or done by some sort of AI, but then there is still the human who is making the decision on top. And that's how I think, as I think kind of alluding to earlier point that Jamie made, that you are still assisting the humans to help with all the analyzing of the data. The human is the one who is taking the decision at the end. and that is what accelerating. So the humans is still there, the engineers will be there who will be taking the decision of go no go, good or bad, how to improve, but then they will have much faster data incoming with much better analysis ready to evaluate. Yeah.
I
Mhm.
think to add further to
Okay.
that, it was a very good question from the audience. Um, the AI could also have the capability to assess whether the data coming off the scan is good.
Mhm.
There's always, you waste a lot of time if you've scanned a part and there's something's gone wrong with the process, and then you're checking through the data to see actually what's gone wrong. Is it an equipment error or something else? So using the data, using AI to very quickly assess if you can trust the data that's or the inspection reports that's come off the C scan. Again, that will just speed up things incrementally.
Mhm. So this is definitely like plausible uh, application, but a lot of work needs to be done before we
Mm.
can implement this. Okay, great. So thank you for your response, Jamie and Praveen. I hope this answers your question, Naresh. Then we have another question, and it says like, can AI realistically enable first-time right manufacturing for flight-worthy composite parts, or will it remain largely a decision support tool? Praveen, would you like to answer that?
Um, so I think there is a capability that actually we have been kind of pondering while we were writing one of the research proposal in this regard. There is a possibility to be able to get the part right. It's all about having the right model ready. So I think it's about the technology maturity. I think we can get to that. There are certain places where you can already kind of get to. So I give an example of in the fiber placement process, what you can do. You can have your sensor analyzing the incoming tape, the place tape, and the bonding quality with all the sensors. And you can also take corrective actions. So you can get the layup first time right. So now I got a subtask within the entire process chain, right? I think that same could be done at the tooling stage, at different stages. But the technology stack is not ready yet. So the AI actually can enable it, but you have to build this. There's a sensor infrastructure, then there is the AI that is with right trained data set, infrastructure, and then there is the logical reasoning on top of that, and that can enable basically what we call a lights out system. You basically turn off lights, you go, you have inputted or provided all the data, materials and such, and okay, this is what I want to make, and it's making it. So that's kind of what you would definitely want to achieve, but the technology stack is not isn't ready yet completely for composites, I would say.
So it would
Yeah,
be an ideal case.
I'd agree with that. I think the technology will get there, and technically it'll be capable of doing it. And um, the other aspects of it is if there is a part that might not be conforming or to usual standards, whether you could use the AI, the data combined with AI to automatically contest the part. That could also be a step towards um, parts that might be unnecessarily NCR. I think again it comes back to that trust thing. The technology might be there, but the maturity and the trust in the part in the technology will probably lag behind technology development itself. So particularly in highly regulated industries, I think it'll take a very long time for people to trust, fully lights out manufacturing.
Mhm. So, someday we would definitely want this to be the case, but right now it's not the scenario, I think. Okay. Okay. Thank you for your response again. Now Coming to the next question, it's from Dr. Sampath. And Dr. Sampath asks, can these tools help with designing production of low odor, low VOC composites and master batches? I think, Praveen, this is directed to you back when you were describing about the tools.
I don't know, but I think it kind of is more on the chemistry side of things. This is what I'm not my area of expertise. I'm a mechanical engineer, but I think this is a
Mhm.
very pertinent question because I have worked starting days with the hand layup process, and I would like not to have odor any volatile content coming over me, getting headaches, and getting hands more itchy or such. I think that this is something what definitely all the resin system providers should aim for. Like I know that we would want the TG to be higher, the strength of the matrix should be better, better outlife, better, all that. Plus, we would like also now slightly more, kind of work-wise, we want it to be a bit nicer material. So yeah, I think this is maybe I'm not the right person. I'm not sure either of us here, but it's the chemistry of the hardener and the matrix and how they they behave. Yeah. Yeah.
Okay, so AI has little to contribute in this regard.
No, it's just the people from chemistry should use that AI, and not like
Okay,
us. I would say, yeah.
I suppose there could be
and
an application. I'm thinking, I had some experience with some aircraft interiors projects, um,
mhm,
and the traditional materials that are used in aircraft interiors are pretty horrible to work with, and you need specific um, extraction to make sure you're not killing your operators. But there are, um, let's call them healthier prepregs that are being developed that still have the same fire retardancy or FST properties as those more traditional materials. And I guess there could be an application there where to get them certified and get them into serial production, it's just going to take time because you need to do so many qualification tests. Whether there's an opportunity there to use AI to speed up that process or be able to interpret data from a fewer number of tests um, to give the confidence to qualify that material for those processes and yeah, take away the horrible chemicals. Um, yeah, same as Praveen. I'm
okay,
mechanical engineering by background, not chemical,
mhm,
which yeah,
yeah,
I'm very much treading on on soft ground here.
okay, great. So definitely this is something the resin manufacturer should be looking at. And thank you for your response, both of you. Now, we have another question from Arnab. And Arnab is asking, like, what is your view on the future of natural composite? Like, I think he is meaning to ask how AI will deal with natural composites. I, yeah. So, Jamie, would you like to take this up?
Yes, I've been interested in natural composites for a while, and I think it's the same challenge as kind of recycled composites, where they're for them to be successful, there needs to be a viable business case. And I think with natural composites, there's particularly natural fiber composites, there's limited markets for it still, or limited applications for it, where carbon fiber or glass fiber would be the more either high performing or cost effective option. I'm not entirely sure how AI specifically will help with that, but it's it's maybe looking at understanding the business cases, for those specific applications. So I know, flax as an example has very good vibration damping properties. So to get that into serial production or through development into serial production, maybe there's an application there. Going back to that idea of being able to qualify materials through a reduced number of tests, particularly for the kind of less structural applications. Maybe there's an opportunity there for using AI to support that. Yes, interesting question.
Mhm. So some of the challenges are going to be similar, whether it's natural composites or carbon composites. Okay, great. So thank you for your response, Jamie. Now we have a lot of questions, but I don't think we can take them all today. So just a few more questions, if you wouldn't mind.
Go ahead.
Is it okay? So I'm going ahead with the next question, and it is from you, Ravi Goda. Ravi Goda asks, can AI replace the methods and manufacturing engineers completely in composite industries? And how AI can be used in these positions to reduce engineering time? I mean, you would like to
Okay.
take that?
Yeah. I think this is kind of in my wheelhouse, I feel like,
Yeah.
because I've been now like, so there is the automated fiber placement, which is like well known, well established processes. Now we have kind of working with this large format continuous fiber printing type of approach, where you are able to do tooling and placement and maybe reinforcement of that substrate itself. I feel there is definitely an iteration possible here, where you have a tool head or kind of a combination of multi tool head that could be on a motion platform, where each of the individual end effectors are able to do their part and produce the composite part pretty straightforward, just given nothing, and you input like a CAD model with all the details of your design, and you have your tooling ready, you have your layup onto it, you have your part qualified with the inspection and such. And I think that's kind of within reach with the capability of AI that I can see today. It just is not built yet. So, but yeah, I think the very good example I like to point, and this is like a electro impact system, which is like I don't know 5-10 million euro system, but it's a good system that kind of highlights that you can print washable toolings and with the placement on top of it, or you have high temperature polymer printed and then tooling printed onto it. So you have continuous fiber printed onto it, and similar to what we also do with our ADAC system, it's you're able to print basically any high performance polymer or this washable tooling, and then you can place either tapes or filaments of continuous fiber to create the structure, and that could shrink your design to production in because it is all happening in one single system. You can have it like 2 to 3 days, which usually would have taken tooling cycles to materials placement, different setups with different machines all together combined, not less than a year for an initial version. So this is not for high production volume. This is for like creating new design ideas and actually proving them for
Mhm.
production. I think this type of thing is possible, and this is like my would be like the dream system to have in home. Like, okay, I would like to have a carbon fiber bike, and that makes it, and I'm very happy about it. Yeah.
Yeah, okay. So completely self-operating system is definitely possible, but not right now. That's what you're saying, and that too only for small applications,
And the small volumes, the applications could
small
be
volumes. Yes, yes.
definitely the volume is the limited by the machine's own
Mm,
production volume, but the you can produce not that many parts. Let's say one part takes 3 days or so,
mm,
because you start to print the tooling, then you have to machine the tooling, finish the tooling, then you do the placement on top of it. It's thermoplastic, then okay, it cures rapidly, but then you do inspection on it, and then you take out the part. You still can have to do some finishing operation on it. So it's like about 2 to 3 days worth of work, and this is not less than 1 meter size of the part we are talking. So that's the I think it's ready already technology today.
mm.
So I think that I see it getting better and getting more adopted because AI makes it all possible to be possible within one system. in that
Mhm,
way, quality assurances, tooling design, and all those things. Yeah.
mhm. Okay, very interesting to know. So, thank you for your answer, Praveen. I think uh, the audience must be satisfied with the answer as well. So, just one last question, and that is again from you, Ravi Goda. And Ravi Goda asks how AI can be used in business development to grab the orders in composite startup companies. Jamie, this is definitely for you. I think you were previously explaining how you are helping the salespeople as well. So, what do you have to say about this?
Yes, good question. Um,
Just check before you answer if you are helping a competitor here.
yeah, yeah. I won't give away the secrets. There's no secrets. How can AI be used? I think it's um, again decision support. So being able to um, assess your potential customers and prioritize which ones um, are most likely um, to place the orders. In composites, the sales cycles are particularly long, um, just because the um, just because of the nature of the business. So I think being able to prioritize your time and be able to support answering questions from the customer with real data, and improving the efficiency of your sales teams is where AI can support the most. Because composites is such a um, complex product, you could you have to have a lot of technical involvement. Either your sales teams have to, or sales managers need to be very technical, or you have to bring in technical people to answer questions, which again can kind of slow things down. Um, and also, your competitor when you're trying to sell something will be um, might have a more technical salesperson, so the sales cycle can be easier for your customer. Because one of the most frustrating things I think is if I'm trying to buy something, um, if I keep asking questions to the supplier and they have to say, okay, well, we'll come back and we'll answer that question in the future. It can kind of slow things down, and you don't build up that trusted advisor position.
Mhm,
So I think having an AI algorithm that can support, this is going to sound like a sales pitch, but that can support quick answers like what Pliable is doing, um, where we can assess the customer requirements, assess what's missing very quickly, and provide immediate feedback. I think it just makes everything a little bit more seamless um, for the companies. Um, what AI needs to be, or if you're a startup working in composites and developing AI, it's just important to make sure that you've got that human face as well, because as the cliche goes, people still buy from people. But so they don't just want to see a black box of AI that's an AI chatbot giving you the answers, but making sure that again you're combining the salespeople and augmenting them with AI. Then that's where I think the main benefit in using AI to help build orders can come from.
mhm. Okay, definitely. I think that would help a lot. And definitely, even I think that AI can, while AI can help you in crafting the pitch, it is some expertise that you need to showcase when you are interacting with the client. And otherwise, it's not going to be like you're not going to be able to win the trust. And definitely, it will not be a good deal in that case. So, one last question we have, and that is, uh, it is from Mr. Aditya Joshi, and he asks, this is definitely not a technical question. He says, just out of the league question to both, is the industry having FOMO like other industries do related to adoption of AI? FOMO as in fear of missing out. So this is for both of you, I think. Who would like
I'll
to
let
go
Praveen go
first?
first.
I think composites industries have that nature. Unfortunately, I would have liked like everybody's rushing to get some, you know, AI tool out, but at least what I've seen is a bit more measured like usage. Already in the beginning, I would say there was because there is already like a lot of concern what a organizational data can be uploaded, what actually you cannot use any customer things, so you have to really think and you have to be very careful of okay what type of information you can upload to seek more contextually relevant answer and such, and you are very limited in that way, and because there is so many, I, to be honest, I don't know, but I am pretty sure I almost every day sign an NDA. So thinking of that, I don't upload anything. That is from the so given that just the adoption has been very slow in that way. Nobody's having a FOMO. Everybody's doing very measured. Everybody got some got like we have a chat GPT that I need to ask some question, or Cloud or Gemini, but that's about it. And then I would say that's kind of where we are at the moment. I don't know, Jamie, what has been your experience?
Yeah, I think it's the same. I think everyone's very interested, and it's just the nature of the industry that we're dealing with engineers who are very logical most of the time, and very measured in their approach. So we're um, yeah, we have a lot of discussions about how the AI works, what the challenges are, and then the next stage is always we'd like to try it. So we do smaller projects with customers to try it, and then we go on to the bigger projects when we build up that trust. So um, yeah, I wouldn't say it's FOMO as such. It's just more, yeah, exactly as you say, more measured. Um, so yeah, the pace is perhaps a bit slower than other industries that are, yeah, maybe less regulated, and people are just, yeah, keen to go for it. Um, yeah, very good question though. Interesting.
Okay. So while other industries are having FOMO, the composites industry is okay with the pace, I guess.
Yeah.
Definitely. Okay, so I think we are good to wrap this session. And for now, if we have any additional questions, I can just mail them over to you. And then if you have the time to answer, I can send the responses back to our audience. And before we close this session, just one wanting to know your perspective on how do you see this industry 5 years from now, the AI part. What things do you think will be completely automated, and how do you think the regular manufacturing procedures will have changed in the next 5 years, giving the penetration of AI? So we'll start with you, Praveen.
Yeah, I think this is once again more wishful thinking. So I'm a big fan of robotics, and as you can say from just the poster behind me, I think we start to see hand layup or more this type of layup, but with like Optimus type of robots. Those robots are not that expensive compared to industrial robots, and I think if we can kind of get them like good enough vision model by then, they would be able to do like large enough part layups, for specific complex geometries where AFP is not sufficiently able to do those complex parts. So and then we can get actual people away from the order and the VOCs we were talking about a while ago, and that way I would say the composites could become then a bit more free. Okay, this can be designed even though this may require more hand layer, it can be scalable because the robotics is that would be my um wishful thinking, hopeful prediction. In 5 years we start to see a lot of this layup. Yeah.
Specialized robots. Okay, that's great. So what's your take on this, Jamie? Where do you see the industry?
um, I think very very similar to Praveen. I think we won't notice it coming in. It'll just be the norm, that we're using AI a lot more in the design process. Um, it's it's basically like how quickly ChatGPT and Gemini have just become the norm. So I think we'll just suddenly just be used to using them, and I think particularly in the design phase, I think it'll be, well, hopefully coming from a pliable perspective, lots of people will be using our software to design their tools, and it'll be in 5 years' time, it'll have a huge amount more functionality. So your engineers won't be spending ages designing tools; they'll just plug it into pliable, and then they'll be there to check it and probably say, yes, this is great, let's move on. The same on the robotics and automation side. I think we'll be seeing a lot more robots and a lot more automation in composites manufacturing throughout the whole process, from layup through to inspection at the end, all with engineers over the top. But things will just be a lot quicker and a lot more efficient. We'll be using less materials, there'll be less wastage. I think we'll be sitting here in 5 years' time thinking not much has changed, and then you reflect and suddenly you realise that there's robots everywhere, and we're using software tools to do the majority of our design.
Mhm. So you would basically like to make the life of engineers better by improving your product much more. Okay.
Or they can do more work harder. I'm joking.
Definitely.
We
Okay.
need
Thank
actually
you
more
very much.
planes to fly cheaper, it's always needed. So
That's true.
Okay. So thank you very much for your response again, Praveen and Jamie. Was a really insightful session. We discussed a lot of interesting things, and I hope the audience enjoyed as well. Now, before I bring this session to an end, I would like to mention that composites manufacturing is a broad topic, and so is AI in composites manufacturing. And there was only so much we were able to cover today, I think. And for that, we are currently working on a free white paper, which will be published in our portal very soon. Jamie and Praveen both have already been contributors to that paper as well. And you can see the download link for signing up in the screen flashing in front of you. So anyone who might be interested in accessing the paper might just scan the QR, and it's completely accessible for free. So it's a no cost download. So thank you very much once again for joining us for the insightful session. We plan on keeping conducting such sessions throughout the year, and we hope we will get to interact again soon on such insightful and interesting topics. So have a great day. Bye bye. Thanks. Thanks. That's it from my end.
thank you
Thank
for
you.
the invite. Really nice chat. Thank you, guys.
Yeah. Have a great day, Praveen. Bye bye, Jamie.
Bye.